All right. Good morning, everyone. Let's get started with today's class. So today our goal is going to be to finish that NASS spatial script, where we're basically going to be doing some geospatial operations there, some of which are going to be really important for you to keep in mind and remember, because they're really the first steps that you're going to be doing really in any geospatial data analysis in R. So it's going to be a good foundation. And then after that, we're going to talk about the mini project. So we're going to introduce that today, and you're going to have about 2 weeks to complete it. So we're going to go through that, instructions, what I'm expecting you to do, some tips, and so on. All right, so what I'm going to do now is just to navigate to the course main folder, and we were working on the 03 NASS project. So if you don't have an RStudio window with that project launched, please go ahead and do that. I'm going to go inside that folder and do that by launching that rproj. And again, I'm going to be repetitive for a while, but always make sure that you launch your scripts from within the project that that script belongs to. Do not simply go on the code folder and just double click on that script to launch it, because that may bring you into the wrong project, which may cause issues with relative paths importing and exporting things. So to keep your sanity, make sure you launch that RStudio project and that it pops up on the side. All right, so as you may be seeing on my screen here, when I do that, it already populates it already pops up that script that we were working with last class. If that is not the case for you, click on that R blue button on the Files tab. That takes you to the home folder of this project, and then you can navigate to code and launch your script that way. Okay, so in my case, as I hope it's also yours, since we did that, we changed that setting by design, your environment is probably empty, which means that even though we have already worked with this code last class, we're going to have to rerun the code to get to the same spot where we left off. There are a couple of ways you can do that. So one of them is if you have no issues with the code above, you can just come to whatever chunk you think is the next one to be working with. So in our case, I think we were about to develop the soy SP object. So this is not developed yet, but if you come to this chunk and you hit this button right here, it run all chunks above. And again, if you do this, there's going to be a progress bar that shows up at the bottom that's going to show you the progression of running the chunks above. However, if you left any lingering piece of code that is not working on the chunks above, this will not work. So if that is your case, then you're just going to have to come to each one of the chunks and just play them. And as a reminder, make sure that your install.packages or install_GitHub functions are inactive by adding that hashtag in front of them. And I do believe that so people that were having issues installing USA boundaries, I think you got back to me and you told me that you were successful in doing that. So I'm assuming that you were able to load this package. We're going to be using that, or I guess we already used it last time, but we're going to use it again and continue using it today. So if you have issues with that package, that issue would come up here. So the US counties function is basically giving us the boundary of the counties in Georgia. So if this function here doesn't run for you, that's because you have an issue with the USA boundaries. All right, so just quickly going through what we did. So on the script previous to this one, we got that NASS data that was directly from the NASS portal. We processed it, and then we exported it using tables and plots. And then we exported that Wrangle dataset as soybeans NASS process.csv. Now on this script here, we're basically bringing in that process version, so we don't have to do all that processing again, all the wrangling again, But we're bringing in here, and then we're gonna make some maps. So, we're just going through here. When you read this, this data set should have 5,877 rows and 4 columns. And we see here that the columns we have is year, county, production in bushels, and production in million bushels. Then, if you look at this data, really our goal is going to be to connect this, which at this point is just a data frame. It does not have spatial information yet, but it has something that can help us to connect to that spatial information, which is the county name, right? So everything that we need now is a geospatial vector object. In this case, going to be an SF object because we're using the SF package. So that's the class of that object. That is going to also have a column called county that's going to have the names of the counties, and then the polygons or the shapefile of those counties. So we need to combine both of these data sets using a common column. In this case, that common column is the county name. This action of combining two data sets based on a common column, in our case, again, the county name, is also a very important task that you're going to find throughout your careers when you play with data. And I'm going to show you one way, especially if one of those objects is geospatial in the case of the Georgia counties. Okay, so SOIW, this is what it is, not geospatial yet. Then we created this Georgia county object using that US counties function and asking for the state of Georgia. If you do, if you ever need shapefiles of states, counties, even cities, this package USA Boundaries has other functions that you can use the same way. So just as a reference. And then just to make sure that we are getting what we think we're getting, we just made a plot using ggplot. And we talked a little bit about this geom_SF. It is a specific geom in ggplot to plot SF objects. So it already takes care of a lot of the background things for us. So it knows that because it is an SF object, it is a geospatial object, X and Y axes are coordinates, right? So you would not say X equals to county name. I mean, you could, but it would not be a map, right? It would be maybe a box plot or something else. So geom_SF makes sure that takes care of the X and Y axis, plots it for you. And then, of course, we can further customize this if we wish, which we're not doing that quite yet. So we talked about this issue of SOIW having some values here that are like other counties and also other combined counties. There is no way we can connect those with the geospatial extent. So we're basically filtering them out by saying to keep the county values that are different, and this is how we specify different in programming language in Boolean operators than other counties and also different from other combined counties. And then finally, we, if you remember, all the county names are uppercase, and to make this, I guess, easier to read, but also to connect well with the other data set that has the actual county names and geospatial data, we're just changing these to title case, which is basically just the first letter uppercase. So if you run this, we're assigning that to a new object called SOIW_all. And if you run SOIW_all, now it has a few, or it has fewer rows because we filtered out those county values that were other counties. And also now the county names are in title case. This is this str to title is coming from the string R package. Anytime you're dealing with strings or characters in R and you need to remove something or maybe find a pattern in those strings, or maybe, in this case, change the capitalization of that. Look into this package. It's a very useful package and has many other functions that I'm not showing you here because we're not needing them, but it's a very useful package. Okay, so next we were just doing a very light processing of the Georgia County object, basically because Georgia County, so it is that object that we retrieved from the US counties function. it provides us with a lot of information, and perhaps this could be useful in different settings. For us, really everything that we need from it is this geometry, which is the polygon of each one of those counties, and then the county name, which in here, in this data set, that column is called name. And I want this column here to be called the same as in the previous data set, which was county. So we're just doing a select to keep just that name and that geometry. And then on the fly here within the select function, we're renaming that name column to county. So if you run this and you print it, now we kept all the 159 rows. Remember, each row here is a county. Georgia has 159 counties. And then we now have only these two columns, county and geometry, because we did that select right there. And this is where we stopped or left off last class. So now let's start developing this script again. So
Excuse me. I wanted to ask what
Yes.
GeomeSF is. GeomeSF.
Sorry, I missed the beginning of the question. Can you repeat that?
GeomeSF.
Yes, what's the question?
Can you tell me what it is? How is different from geom underscore line?
So in ggplot, we have
Yeah, this
multiple
one.
geoms, right, which are related to how you want to show your data. So in this case here is a little bit of a special case because the object that we're plotting is actually a geospatial object, right? So because it is a geospatial object, there's nothing like geom underscore boundary. There's not something like that. What we have is geomSF. So geomSF is a geometry function within ggplot that can only be used with SF objects. So if we check here the class of Georgia County, it is an SF object, right? So geomSF only works if your data that you're providing here is SF object. And when you do provide an SF object, I'm just going to print Georgia Co so you can see again. It is saying here that's a simple feature collection. It has a geometry type of multi-polygon because each one of those counties is a multi-polygon themselves. And then it gives us here a little bit more information. So the bounding box, which is normally something that we get from geospatial objects, and also what is the geodetic coordinate reference system, that is WGS84. So GeoMSF basically takes into account all that information, and then it already assumes that on X you have longitude, on Y you have latitude, already places that on X and Y, and just shows you whatever you're providing it. So let's just think of a different example here. So if Georgia County was actually a point vector geospatial file rather than polygon, then this would be, for example, if you take gridded soil samples and you're taking the coordinates of those points, or maybe you're sampling something on the field that you're taking the coordinate of whatever you're sampling, it would also be an SF object, but instead of being multi-polygon, perhaps would be multi-point type. In which case, if you do plot it with the same way here, with the same geomSF, it knows that in that object it doesn't have polygons, it has points, so it's actually going to show as points. So geomSF is doing that guessing for us behind the scenes, so you don't have to be super specific if you want to show something as a point or if you want to show something as a polygon, because it gets that information from the object itself, right? However, if we're not using geospatial objects, so let's say what we did previously as far as plotting a data frame, right, that we wanted to show, I don't know, the points of something or a distribution of something or a line of something, then we need to specify on the AES function what goes on X, what goes on Y, if we want to color something according to a column, and so on, right? That is not quite the case with GeoMSF, at least not for X and Y. Of course, we could still come here. So let's say, I'm just going to do a quick change or a quick demo here on the fly. Let's say I wanted to, let's see, I don't think there's going to be anything that is so let's say I wanted to color the polygons according to a water, which I'm not quite sure what that is. We would have to go back to the documentation of the function, but it's probably the area of the county that's covered with water bodies, I'm guessing. In some unit, I'm not sure which unit. So but let's say I wanted to color the counties according to these values here, right? So I could come here, I could provide an AES function and say fill equals to a water, and this would basically do that for us, right? So you would still use the AES if you want to change color, fill, transparency, things like that. But X and Y do not need to be provided. So here it kind of makes sense, I guess, because the counties that are, I guess, that have a boundary that is shared with the ocean have greater water proportions of that county. So that kind of makes sense, I think. But yeah, I guess I just wanted to show you that. So remember that with ggplot, it's going to basically, you need to tell it how you want to show that data. And if it is tabular data, so non-geospatial data, it will need to be more specific if you want to show as a point, as a line, as whatever you want to show. And there are different ways of doing that. But with SF objects is a little bit more straightforward because it kind of reduces your options right there because it's going to guess what type of geometry is using based on the actual SF object type. So if it is a line or a polygon or a point or so on. Also, Kumar, I did see your email. I didn't get back to you yet, and I saw your GitHub issue question as well. And I just want to say, so what I'm showing you here are just some examples that I think can be directly related and relatable to you and what you do. However, it's not an exhaustive list of examples, right? So if I just want to provide a quick reference here. So all these packages we're using, so ggplot, dplyr, PyDR, SF, others that we will use, they all have what is called a vignette, which is basically kind of like a tutorial showing you some of the main functionalities. And most of them also have a cheat sheet, which basically, in a very concise way, shows you the most important functions and how you would use them. So let's say, if I want to come here and say ggplot2 cheat sheets. So it opened this page here on Posit, which is what our studio is. So the company is called, and this is just a ggplot2 cheat sheet, right? So it shows you how it works, some of the basics. It exposes you to some of the geomes that you can quickly see there. And of course, it doesn't provide you a lot of examples, but at least it gives you a very quick overview of what it does and some of the main functions. And then, of course, if you come here and you think, you know what, I would really like to learn how to do a geom ribbon, for example, which I use a lot especially with like weather data over time. So you may show a line as the mean, but you may have a ribbon representing the minimum and maximum around that mean. So then okay, I need to use geom ribbon for that. So then you go on Google and you say, ggplot2 geom ribbon examples, and you're going to find. Right, so this is just to give you some idea of some of the geometries you can use, and then you can further explore that elsewhere or look for that elsewhere. All right, Kumar, was this helpful? Do you have?
Yeah.
All right, so let's continue here. So we were at this step here where the immediate next step is to join that NASS tabular data with the actual geospatial information that we're getting from the Georgia County objects. So I want to call that soy SP. That's going to be the next object that we're going to be creating. So let's start off with our so Georgia _county _W. So that is, again, our Georgia County data with the geospatial information. Let's give it a type, hit return, and the function we want to use here is called left join. And then here we basically say, what is the data set that we want to left join? So the data set that we want to join here is the soy_w_all. So the soy w all is the one that has like 5,000 and some rows. Georgia County only has 159. So if we do this, notice that it gives us a message here saying that it joined by county. And the reason why it's telling you that is because it looked into Georgia County W and it found a column called county. And then it looked into soy W all and also found a column called county. So they share the same column name and they also share column values, right? So even, let's say, even if they had all the same column name, so both of them named county, but if one of them was actually all uppercase, like was the case of soy W all, that join would not work because even though the columns are named the same, but the values under them are different. So that's why we had to transform to title case one of them. So if you run this and you print it, now notice that we have 5,469 rows, which should be, well, is maybe 30 rows less than soy W all. I'm not quite sure why, but let's just keep going and see maybe when we plot, we're gonna be able to see what's going on. But now notice that this object, the soy SP object now, is actually a NASS object. So it's a simple feature collection, right? So now we basically transformed, or we merged the field data from NASS with the geospatial information from Georgia County object into one. So now we can actually create plots like what I was just showing you, but now we can actually plot production instead of water area with water in account. All right, so the first thing that I want to do here is create a few static maps with this. So we're really going to be exploring a little bit of, further exploring how we would make a plot here in ggplots. So I am asking here to plot the 2022 production by county as a map. So just to print here, soy SP, just to refresh your heads, soy SP has over 5,000 rows where we have multiple counties, or whenever, if a county reported data, that county is present in that given year, and then we have across time, right? So if I do want to plot the 2022 production only, what should we do here? What should be the immediate next step here? I want to give a pipe hit return already to be ready for whoever can help me. Did you say something, Eva? No, Renalisa, did you say something? Filter, yes, I like it. So remember, filter applies to rows, select applies to columns. We want to filter rows where year is equal to 2022. So filter, the column name is year, all lowercase. So year equals to 2022. Right, so by doing that, now we were only left with 18 features, meaning 18 rows. What that tells me is that in 2022, there were only 18 counties that reported this data here in Georgia for the soybeans production data in Georgia. All right, so we already made the query that we needed, so just 2022. Now let's add a pipe and get right into ggplot. So I want to call ggplot here, just leave at that. Remember that if it's coming through a pipe, the data argument is assumed to be everything above that pipe. So this is what's coming into this data argument. If we just go ahead and plot that, I mean, we basically get nothing because it is an SF object. So it is only going to know X and Y once we call the geom_sf function. So let's add a plus here. And let me tell you, let's see. Okay, let's go ahead and do this. Let's get started with the geom_sf function. Okay, so just again, I want to be repetitive. Geom_sf is the geom that we use to use ggplot and make a plot when your object is of type SF, and objects of type SF are geospatial vector objects, right? So you can kind of think of this as your shapefile if you're used to that terminology. This would be your shapefile that we use geom_sf to show that shapefile in a map. So just to make sure that, let's see, let's go ahead and try this. If I want to, well, if we just run this, we get this map here, which looks kind of odd, right? Because the reason why it looks kind of odd is because we're only showing the polygon of the counties that reported data in 2022. Let's keep going, at least with this geom_sf, and then we'll come back and fix this in a second. Okay, so if I want to, let's say, have the fill of these counties here change according to production, you should be, every time I say I want to change something about this plot according to a column, in your head, you should be thinking this has to go inside the AES function somewhere. In this case, we're going to come here on this geom_sf, type in that AES, and I want to say fill equals to, and the column is prod, MIBU for million bushels. If you run that, then you get your counties colored by production million bushels. We see here that the county, at least in 2022, the county that had the largest production, which was about 0.4 million bushels, was this one in South Georgia. I don't know exactly the name of the county, but we're going to show county names in the next chunk after this. But you can kind of just see by the colors that this one is the highest, probably this one is the lowest of the ones that reported, right? All the others were either not reported or perhaps they were combined into those other county categories, which again, we cannot really know which ones they were. All right, so now how can we fix this? So let's say I wanted to show all the counties in, so a map with all counties in Georgia, and then only color, and then show this on top. So only color the counties that actually reported data in 2022. How do you think we can achieve that? Any thoughts?
We can also attach the data that we have developed earlier under GA_CO.
Yes, that's it. That's the direction. Thanks, Kumar. So Kumar said, we can show the Georgia County. I think we want to show the Georgia County W, perhaps, but that's the one that has all the 159 counties, right? So let's go ahead and do that. So remember that in ggplot things are sequential and additive. So to add something else to this plot, you would add a plus, hit return, and then add that something else. So that's something else that Kumar is saying that we should use. Well, so it is going to be let me write outside the chunk so it doesn't run. It's going to be the Georgia County W object. So this object is an SF object as well, right? So what is the geom that we need right here?
Hey, Professor, I got an error here in Chieftain
Okay.
on the left join. I was trying to troubleshoot by myself, but I couldn't.
Okay, what is it telling?
So it's telling the SF column percentage in percentage names. SF column names. This is what it's showing for me. I did the same thing, but I gotta join the
So what I would
meeting.
sorry, go ahead.
No, we're just gonna join on the Zoom with my computer to
Oh yeah, you want to
share this.
Sure.
Yeah, I think it would be better to explain.
Yeah, go. Let's see.
Let me open here.
Yeah, so while you do that, is that Vinicius?
Yeah, it's me.
So my first guess here is that perhaps your column names are not matching across both of those objects, or
Me.
the other potentials. issue, I guess, could be if you did not use the title case on the NASS data. I'm guessing it's going to be one of those two. Oh, wait, I think I have to give you permission to share.
I just gonna open you.
Yeah, my guess is that would be one of those. So if the left join, so because the left join again is relying on you having two common columns across those data frames where the column headings should be the same and they should share, the values should be in the same format as well. While Vinicius,
I just opened the Zoom here. Sorry, it's taking a little bit longer than I thought.
no worries. So while Vinicius is working on sharing his screen, any questions or issues from, anyone else?
Yeah, I also in Tipton, I had a question about that last thing that we just did. I know, so we got to show the counties that reported production, but is there a way that we could show that all of the other counties so that like the state of Georgia is filled in and it's not just kind of trying to guess which counties are which?
Yes. So that's what we're gonna do right next, after troubleshooting here with Vinicius. Yep.
That's the problem that I got here.
Okay, so even though the beginning, so let's go through this together here. I don't know if people here in Athens. So Vinicius, can you push? Are you working on a Mac or a Windows?
And Windows.
Okay, so I think it would be Control Plus. If you push that in your keyboard, it may increase the font size in our studio. Yeah, there we go. If you can do that one more time, just so it's easier for people to see here. Okay, awesome. Okay, so let's show your error right there. So it's saying here that X, so if you look at the second row of the error, it's saying that X and Y have no common variables, right? So basically, it's probably that when you created the Georgia Co W or the Soy W all, you did not get their names to match. So if you go up on your script, maybe let's see on mine here. Yeah, right there. So the Georgia County W on my side, I have the select, but then I'm saying county equals one equal sign. So county equals name, because then we're selecting that name column, but we also renaming it to county on the fly. So on row 89 of our script, if you say right before name, if you just say county and then equal sign. So if you go before name, so you have a cursor right before. So it would have to be, so you can delete that and just move your cursor. Is that the other way around? So it has to be county equals name. Yeah. And that's gonna do the trick. Yeah, and then if you run that chunk again, so you create again that object, and now you go to the left join, now it should work. Yeah.
Okay, I got it. Thank you.
Awesome. All right, let me, well, once you stop sharing yours, I'll start sharing mine again. All right. Okay, so we stopped at this point here, right? And the immediate next step that we're gonna do is to show out all counties in Georgia and then bring in just the 2022 ones on top of that map and only show the fill ones right there. So if our immediate next step is to show again another SF object, what geom should we use here? Send us. What do you think? GeoMSF, right? Again, GeoMSF is what we use when we have an NASS object, which at least until now, all of our spatial objects here are SF. So then here we would say, because it is a different data set, we would say data equals to, and the name of the object is Georgia County W. So let's just go ahead and run this and see what happens. Okay, so what happens here, and I think this is a great point for us to think about this, is ggplot is sequential. And that means that it first adds what you ask first and then adds what you ask later on top of it, especially if you're adding geomes. So in this case, basically what we have to do is just swap the position of the GeoMSF Georgia County W, because right now, Georgia County W that has all the counties is coming on top of our production counties on 2022 and is covering that. So one of the ways that we can fix this is just changing the order that we give this. So I'm just going to remove that GeoMSF for Georgia County from the last position. I'm going to move that right after the ggplot call and add a plus, and then have the filter one come through to the second GeoMSF here. Let's see if that works. All right, that worked. So really, but you know, this is an important concept in ggplot. When you're making plots, remember that you're doing sequentially. So the order of the functions that you provide, especially if those functions are GeoMSF, matters. Or I'm sorry, not only GeoMSF. If they are geomes overall, it matters what is the order that you're given it. So in this case, this is what we could do. Yeah, I guess for right now, we can stop right there. So this is a map of Georgia with production, soybeans production in 2022 in million bushels per acre, just showing the actual data on the counties that reported that data, but still showing all counties in Georgia in the background. So we have that spatial context if we're making a map. All right, any questions here? Any issues? Okay, let's move on then. So what I want to do is if I were to do this plot and I wanted to make it publication ready, right? So let's say you want to have this in your poster or a presentation or perhaps in your paper. What are some of the things that we can do here to change this? So I basically, I left the code here as what we did before. So if you go ahead and just run what you already have, it should reproduce the same plot as above. And I just had some comments here of what I want to change in this plot to make it look nicer and more publication ready. All right, so the first thing I want to do is, again, we're going to be using throughout this course, every time we're using color or fill in this course, we're going to be using colorblind safe schemes, color schemes. So to change that, to do that change immediately here, so you come to that last parentheses. This is a ggplot flow. So in ggplot we use plus, right? So remember that we're using pipes when it's not related to ggplot. Inside ggplot we use plus to keep adding things. So if you come here, if we want to change, so you know, an important concept here as well is if I want to assign a column or the values of that column to color, I do that inside a yes, and it gives me a default color scheme. Now, if I want to change what that color scheme is, I need to use a function that begins with the word scale. So if you type scale underscore, you're going to see that there's a lot of things that can come after that first underscore. Alpha means transparency, there's color, there's fill, there's going to be shape, size, a lot of things, a lot of functions to change different things. In our case here, because we're changing the fill, as you can see on that GeoMSF call, we're going to use a scale underscore fill. And even if you add an underscore right here and you just look at the options, there's going to be a lot of options here. And you can play with them if you wish on your side later. But the one that we want to use is called Verities. And again, we briefly talked about Virides in last class, but Virides is perhaps the most popular colorblind safe color scheme that we have really in any discipline, I guess. So you're gonna see a lot on papers, you're gonna see a lot, on presentations or anything like that, this color scheme that whenever we make it, I think is gonna be very obvious to you. A few of the options here are, so just this Virides, the first one that comes from package Virides, and there's a few others coming from ggplot2 that are just for different variable types. So if you're a variable that you're filling with is discrete, so let's say if I wanted to give a different color to different county names as the discrete variable, you would use Virides D, which stands for discrete. In our case, it is a continuous variable, so let's just use the C option. And if you run this is what we get. So this is the Virides default color scheme, which again is colorblind safe. Inside, I just want to show you if you wanted to customize a little bit further. So if you come inside of that scale fill Virides C function and you hit tab, there's going to be a few options you can change here. The one that I really want, you can explore these by doing help and then the name of this function. The one I want to show here is option. So this option here, this argument called option, it takes the values A, B, C, D, I think is through F perhaps. But if you say option equals uppercase A, it's going to give you a slightly different type of Virides scale. So you can just play around, do a B, do a C, and these have different names. Like if you were to use this in QGIS or ArcGIS, this would be called, I think it's like magma and turbo and things like that. So this is just a way of retrieving those different types here in Virides. I believe the default value that it gives you if you do not provide an option is D. Yeah, that's the default one that gives you, but you can change and you can play with this more if you wish. Okay, so change that to be a more inclusive type of color scheme. So colorblind safe in this case. The next thing, so we add a plus here and we go after the next comment is I want to change changing the fill legend label and also give this plot a title. We already used this function before. You may not remember because it was very brief, but there is a function here within ggplot that's called labs that stands for labels. And this inside of this function, we can provide it values of like X, Y, color, fill, title, subtitle, caption, things like that. In our case, what I really want to do is change this right here. So prod underscore MIBU, this is the name of the column, but it's not a very professional way of showing this legend. Because this is associated with fill, because this is where we determine that, we would come here and say fill equals to open and close quotation marks, and then write whatever you want to change here. So I want to propose that we write production, and then having in parentheses, million bushels. Notice how there's the parentheses inside the quotation marks, which is supposed to be just the label, and then there's also the parentheses after the quotation mark, which closes the function, the labs function. So make sure you have both of them and you get them right in the right place. If we run this, this is what we get. What's going to happen to you for sure at some point is you may produce a name that's a little bit too long and you wish you could break line. To do that in R, whenever you have a string or a character like this, all you have to do is just provide the notation \n. So this is the notation that even if you have no spaces between production and million or production and parentheses, by doing backward slash and n, that knows whenever it makes the plot, it knows that it will break line for you. All right, so we changed the legend label of the fill. If we were changing the color instead of fill, you would come here and say scale color Virides, and this would be labs color, right? So just connecting all those things throughout the plots. And now I also want to give this plot this map a title. So I come here after that quotation mark of the million bushels, add a comma. I'm gonna break the code just to make it more visible. And it has this argument called title. The same way, we'll come here, open and close quotation marks, and we can give it whatever title we wish. I want to call this county level soybeans production in 2022. If we run that, now we have that title on top. Just going to give a moment in case you're catching up. Okay, so it's starting to look better. The next thing I want to do is I want to add the county names to these counties. So I'm not from Georgia. I know some of these counties here by being there and by looking at a map, but I definitely don't know where each one of the 159 names would go in a map like this. So if I want to provide that context either to myself or to my audience, we can add labels here. So if you've been working in ArcGIS, this would be equivalent for you adding a label to this layer where it would go under properties, labels, and so on. This is what we're going to be doing next here, but in ggplots. So you come after that last parentheses of labs, you add a plus. Let's come after this adding county names comments. And so here's something that is also interesting just to introduce the concept. If we are adding text based on a column on a plot that is not geospatial in nature, we would use a function called geom_text or geom_label. There's a slight difference there, and we can explore this later. However, in this case is a little bit different because we're adding labels to a geospatial vector SF object. Because of that, there is a special function that SF has that is geom_SF, underscore label or text. So it's also the same way, but it has that extra SF in the geom name because again, we're working with geom with SF objects, and that the position of that label is going to be determined by the actual coordinates, which is very specific to geospatial vector data. So let's go ahead and use the geom_SF text. Notice how here so this data that's coming through the pipe is being utilized on that second geom_SF actually. That's the one with the colors. But then because we used a different geom_SF as well, that we provided the data right there. Now, just to be clear which data we want to use here on this yet third geom_SF, let's use the same notation of like we call the argument data, and we just use this placeholder here that is tilde dot. So what tilde dot notation means is whatever is coming through the pipe, that is the data I want to place right here. So that's what it means. Because notice that soy_sp filter year equals 2022 is not a saved object. I do not have an object in my environment that I can refer to this specific data frame. So this is what the way you would refer to this if it is coming through that pipe. All right, so let's give it a comma, hit return. The next thing we want to add here is I want to tell this geom what is the column that has the names that I want to add as a label. I hope that when I said that sentence, you were thinking whatever it is, it should go under AES because I'm determining the values of something according to a column. So AES, in this case here specifically, it has another option that we have not seen yet, which is called label. So label is, we say label equals county name or label equals column name that actually has the labels. If I'm just going to print here soyp filter version, just so we can see again what it looks like. This is what it looks like. So we have this column called county, and I want these labels to appear in my map. So if I just copy that and I say label equals county, it's going to do that for us. Okay, so it did that. However, it's a little bit busy perhaps. So let's play a little bit with this and change a little bit. So one of the things we can do is go ahead and change the size of this label, because right now, at least on the way that we're seeing, is looking a little bit too big. So you can come here outside of the parentheses of the yes, let's add a comma. And because we're changing all of the sizes to a single value, I'm not changing size according to a column, I'm changing size equally to everything. It has to be outside of a yes. So we say size, let's try a size 2 and see how that looks like. Okay, so it's kind of on the small size. Perhaps we could play around with this a little bit more, maybe like 2.5 or so on. Yeah, maybe we can leave 2.5 in this case. In a previous exercise, I also changed the color of the labels, because we can see that for some places here, it is kind of difficult to read, especially the low production counties. So maybe let's try to change to white. So we come here, add a comma and say, oops, and say color equals white. I think that perhaps there's just one county that would be a little bit more difficult to read in white, but I think when we had in black, there were more counties that was more difficult to read. So maybe we can leave color equals white in this case. Okay, lastly, I mean, maybe this is already in a good shape. Maybe you would be happy already with this plot. I want to show you one option here that is to use a very clean theme that I think is more helpful for maps like this. So we add a plus at the end there, and then there is this theme called theme_void. Let's try to use that and see how things look like. So, if you look at it, it removed the background, it removed the X and Y axis values and titles. It basically removed everything and just left us with the actual map. And so I want to propose that we keep this map this way. For consistency, to me, it looks like a very professional map, right? So let's say that you did sampling in different counties for different reasons, or maybe you want to show this data somewhere. I think this is a really good shape for that to be shown as. Now, the last thing that we're going to do here is basically to export this this figure here. I want to refresh your mind that when we're exporting a plot, it doesn't have to be a map, but if it is a static plot like this, especially being done through ggplot, we use this function called ggsave, where we don't necessarily, so ggsave by default is just going to export the last plot you made. The last plot you ran, that's what's going to export. And normally that's why we want to have ggsave right after that plot, because then it does that for us. So we don't even have to specify what is the plot. It already takes that into account by itself. So the only thing we need to do here is give it a path, right? So remember that if you hit tab right here, it is going to show you that you are inside the code folder. To get outside of it, to go into the output folder, which is where we want to have the plot saved, you would do a .. hit tab. Now you are in the main folder of the project. You would select output. That's where we want to export this plot. And then we would give it a name. I want to call this soy-prod-22.png. So if you run that, it hopefully is going to give you this message saying that saved a 7 by 7 inches image. Now, if you come on your files tab and you go on your output folder, you should see there soy-prod-22. If you click on it, it's going to launch that on your actual computer. This is a PNG file. This is a file you can, again, embed this into, a presentation, a paper, whatever it is. It's right there. One thing to notice that perhaps is a good thing, depending on the context, is what theme void does and did for us here is that it made the background of the whole plot transparent. this may be good for you if you're using a presentation that has a background that is not white, for example, and you want to have this seamlessly, you know, show up in your presentation without having a white background in the plot. However, maybe this is a problem for you and you wish everything would be white in the background. There are a couple of different ways we can change that. One of them could be directly within theme void. There's going to be an argument here that we can change that. I want to show you another way, which is basically on DigiSave directly. So if you come here on DigiSave, add a comma, it has this argument BG that stands for background, and I can say BG equals to white and run that again. And then if you inspect your PNG, now it's going to have a white background. And similarly, it could be any other color, right? I'm just using white as an example. You could choose whatever color you wish. All right. Any questions at this point? Any issues?
Yes, I am having some problem. I'm not sure, but I'm unable to get this map.
Is it giving you a message?
Let me check. There is message in particular, but still I'm unable to draw this. There is some message, but it is not any warning or error message.
Okay, so let's try to troubleshoot it. Do you want to share your screen?
Yes, sure, I will. Mm.
Okay, I think I know what's going on. So let's go ahead and have your cursor on that soy SB row.
This one.
And run it. So run like Control Enter. Okay, so it is creating a map. And I think I already spotted what's going on, but I want to give the opportunity of other people to also look at this and help you out. Can you do Control plus just to increase the font size so people in the classroom can see better? Okay, perfect. All right. Okay, so what is going on here? Why? Let's do this. Can you scroll just a little bit lower, just so people can see that what's actually coming out of the code? So it is producing the map, and even though he has the code for the rest of it, it's kind of stopping at this point. Okay, so Ujwal said perhaps you missed a plus sign. Is that the case? Doug, what do you see there?
They just have it in federal. But it's missing on all of it.
Yeah, so you're missing the pluses all across, right? So if you run now, it's gonna run until scale fill radius, but then it's gonna stop there because you don't have a plus after it. So you have to add a plus there. You have to add a plus. So right there, I think you would have an issue if you look at your code, because you're closing that parentheses after the quotation marks. You want to have a comma there and then close that parentheses after that title, like at the end of row 121. That's where you want to close that parentheses. Yeah, and there you add a plus. And I think that should work. So let's try to run that. Yeah, you got it. Because I think you don't have the theme void yet there.
Okay.
So that's why it's not exactly like mine, but yeah, so it was just you were missing the connecting pluses there. That's what was going on. Awesome. Yeah,
How do I
that's.
go to
Did you have a question?
No, nothing. I'm just trying to stop sharing my screen.
Okay. Yeah, that's a very common, I guess, one of the first things I look for in code is, are you connecting your pipes? Are you connecting your ggplot statements? Do you have your commas where you need it? Did you close quotation marks? Did you close parentheses and so on? Those are some of the most common, issues that we see commonly. All right. So yeah, so this is how you would export it, and then you should see this in your files, right? So if you go to this folder here in your computer, there's going to be that file right there. You can embed this into presentations, Word files, papers, so on. Okay, so the last piece of this exercise is I want to show you how to make an interactive map, which I think is really cool, especially if you share your reports with anyone, but you share that as HTML, which is what we're showing you how to do with partial files, right? So let's go ahead and do that. The first thing is I do want to, I guess, officially create an object where I'm saving my soy SP filtering only 2022 as the year. So I'm doing that again, but now I'm assigning that to an object called soy SP22. Please go ahead and run that. And one of the packages that we installed in the beginning of this exercise is called map view. So if you come here and you say map view, you know, the first thing that we want to add here would be this object first. So let's go ahead and create a map, pretty much reproduce the map above, but it's going to be interactive. So we give this, there is a whole bunch of arguments that we can change within map view. The best way of really knowing what all of them are is by doing a help function. So if you do a help map view, you're going to find a list of them. But map view also is one of those packages that has a very nice vignette, or in other words, it has a very nice tutorial online that exposes you to a lot of its functionalities. Again, we're not going to cover all of map view functionalities right here. I'll show you some of the most interesting ones that I find interesting. But if you're interested in creating interactive maps in R, especially if you have an HTML output, because then the person can actually interact with that HTML, I'm going to leave it up to you to really explore on your side all the options the map view offers you. I'm going to show you some here that we're going to use with this one. So if we just go ahead and run this function, so just map view soy SP, this is what we get. So this is an interactive map of the US. You can zoom in, you can zoom out, you can click on the county to see the data associated with that county, and so on. So what I want to do is basically all the steps that we did above or most of the steps we did on the ggplot to make this a nicer looking interactive map. The first thing I want to do here is let's add a comma, hit return, and map view. So the syntax of map view is going to be different than ggplot. And that's okay, because they were not made by the same person. We wouldn't expect them to follow the same style of how you do things. So in this case, in map view specifically, if I want to color my counties by production, the way we do that is not going to be through AES function. It does not have that type of philosophy, I guess, or mindset. It has this argument called zcol. So this is basically the color of a z variable. And normally, I guess a z variable is called that way because we are, assuming that x and y are coordinates, and then the z is whatever is the third column that you're using in this plot. So that I think that's why it's called zcol. We're going to come here and I'm going to say, what is the column that has the values I want to color by? So we need to give this in quotation marks. So that's the prod underscore bushels. If you run this piece of the code, it does that for you. By default, map view gives you a color scheme that's already Paredes. So we don't even have to play much with that if we don't want to. So let's say the next thing I want to do is, if you look right here, they are like the polygons are a little bit transparent, which is by default. Maybe you like that, and that's fine if you want to leave it that way. I particularly would like for this to not be transparent and be a fully solid color instead of having this transparency. To change that, we can add a comma here. It has an argument called alpha dot regions. And we say equals to 1. So in programming, I guess, or maybe perhaps in software, generally speaking, transparency is referred to as alpha. You're going to see this. That's how ggplot call it. That's how MapView calls it. That may be how you see across other languages as well. Alpha, in this case, means transparency. And that normally ranges from 0 to 1, where 0 is fully transparent, 1 is a fully solid color. So if I just have 1, I have then a fully solid color right there. I think, it comes out more to your eye. If for some reason you want to show something behind it, then of course, transparency would be the way to go. We don't have anything showing behind here, so I'm good with being a solid color right there. Yeah, I think for now, this is where I want to stop on this map view call. So what we can do next would be similarly to what we did in ggplot, is to add all counties in the background. Right, so if you think of it, one similarity perhaps between map view and ggplot is that at the end of this map view call, I can add a plus and add another map view with another data set and completely different settings here. So let's go ahead and do that. So the next map view I want to add is this object that we just filtered up here. So soy SP22. However, oh, sorry, this is not what I want to show. We actually want to show the Georgia County W. Sorry, that's the one that has all the counties. So let's please go ahead and change that. So this is what it happens because, let me just print this so you can see. Because this Georgia County W object only has one column, I mean, it has two columns, but the second one is the geometry itself. So it only has one column with actual data. MapView is trying to be smart and already give you that column as the variable used to color or to fill all the counties. Because it says, well, you only have one variable, so it's not like you have an option, you just have one. So let me go ahead and do this for you, which in our case is not useful because that's not what we wanted to happen. So, so what we're going to do then is basically, instead of allowing it to treat each one of the counties with a different color that is basically just associated with their name, there's no actual data behind it that would be useful to see. It's just their names. So to keep it from doing that, let's just come here on the second map view that we're using, the Georgia County W. And let's say col.regions. This is how we would change the fill of all of the plots to a single value. And I'm just want to go ahead and say white. So this then, it takes the Georgia County W that has all counties and just makes their fill to be white. Now, before we keep developing this and make it a little bit nicer, I do want to point something out. Perhaps one of the only things that carry over from doing a ggplot and doing a map view is that the order that you add them makes a difference again. So even though we made our previous counties to be solid color, it still doesn't show like that because now we have this white, all counties with a white background showing up on top of it. So again, the same way of fixing it, just similarly to what we did in ggplot, is to basically copy the second map view here, or cut, I guess, remove that plus from there that was connecting the first one to the second one, move that second map view to the top, and then add a plus after it. So now the order that's adding things is different, right? So now it's adding first all the counties with the white background, and then we're adding the county data with production. Now you may have noticed that the way the map looks changed. And this must be a default behavior of map view for some reason that I want to fix a couple things. So the first one is I want to go back to the wipe map that we had before, the US map being white. And also I don't need this legend here, right? Because it's just showing that every county is white, but it's showing every county in this legend, which is really annoying because there are 159 lines in this legend. So let's finish to fine tune those things first. So to do that, again, the first map view here should be the one with all the Georgia counties. That's the one that that we brought in this, it was the second thing we brought in, but we moved that to the first position. I hope you were able to follow that. So the immediate next thing I want to do here is add a comma, and it has this argument called legend. Yeah, I guess legend is the name of that argument. I just want to say legend equals to null, and null has to be all uppercase because then R identifies that that's an actual way of making this null. If you run this, now it removed that legend that was related to the county names. So now it looks nicer. It's only showing you the legend related to production, which is the one that we actually want to see, right? And then the next thing I want to show you, and this is going to be something that we're going to be using a lot when it comes to field level data. So this is not field level data. This is regional data, right? We're looking at the whole state with counties. If you come here on this button, so on this, the layers button right there, it gives you a few options. So the first, or maybe the second, let's begin by the second ones, are the layers that you're bringing into this map. So you can turn them on or off. And interestingly, so if you turn both of them off, and then you turn on the Georgia or the production first, and then you turn on all the counties, it kind of on the fly reverses back to following the order that you turned them on, and so it now has production in the background. So I'm just going to turn both of them off. I'm going to turn on Georgia County first, and then production, and then it's going to look like the way we want. Also, something else to notice is that it has all these different options for you of background, of base maps, right? So if you're in QGIS and you want to show satellite imagery, or maybe you want to show, I think this is the one that's called is CartoDB Dark Matter. This is the name of this style. You can just by hand choose different ones here if you wish.
Hey, question, how do I get the rest of the US to pull up? Because mine is just showing the state of Georgia with like a empty background.
Interesting. So
I get showing the rest of the US.
if you zoom out, it doesn't show the US.
No, sir.
Is anyone else having that issue? Okay, yes, Neva is that happening to you?
My one.
Okay, so it seems like it's happening to some people and not to others. And it has not happened to me necessarily. So I wouldn't have an answer for you right now. I'll do some digging after class and see if there's something related to map view. The first thing that comes to my mind that I would troubleshoot is the map view, the version of the package that was installed. Did you install the package like for this class, or did you already have it?
I believe it was for this class, which I'm not sure. To be honest, I don't remember when I installed it.
Yeah. Do you remember, Neva, in your case? You already had like from the past? Okay, so maybe what I would suggest first is that if you try to install that again, maybe it's a version difference. I'm not quite sure. Others in class, are you being able to see the whole US? So which one thinks that yes, Sanders, yes. Doug, can you, Bernalisa? Okay, so other people are able to see it. So that just makes me think that is something going on perhaps with the version.
Yes, I just went to go like to reinstall it, and it said that an update, I would have to restart it.
Okay.
So
Yeah, so
Yeah.
maybe because it knows that you're using that package in this current R session, so it's gonna ask you that you like, restart your session and then install it. So maybe we can try that afterwards. Let's try, for those of you where this is not we're not seeing the background, let's do that as far as reinstalling the package. The package is called MapView, the same name of the function. So let's do that, and if that doesn't work, please go ahead and open a GitHub issue in our class repo with your code and also your output of what you're seeing, and then we can have a conversation there, because especially because more than one person that's having this issue, maybe one of you find a solution and you can help each other, and if not, then I'll be glad to jump in and see if I can find a solution for that. Okay. So I do want to show you the following. What we're going to see, especially when we start working with field level data. So imagine like this, there's nothing keeping us from working with field level data. If you kept zooming in, you would potentially end up in a field, right? So I'm just changing to Esri worldview map. We can see field level data with map view, right? And we're going to actually do that whenever we get to that point with our in-field data layers. However, the default base map that's going to give us, I believe, is this OpenStreetMap. And of course, you can always make a map and come here and change from OpenStreet to Esri, which normally at the field level is what I think is the most interesting to have as a base map. So we can always do that manually here. But there's also a way to force whatever base layer you want directly on your plot, or I'm sorry, directly on your code. So if we come here and we just run this map view, again, it is by default is using CartoDB dark matter. Let's say I want on the code change that to, let's change to this CartoDB positron. We would come here on this first map view call, add a comma. It has this argument called map.types. That right here, you open and close quotation marks, and you can give these names. I believe it has to be exactly as that. Like if you do lowercase c on the Carto, it's not going to work. So it has to be exactly like that. What I want to propose is that we use cartodb.positron. So I'm going to start typing that C uppercase, Carto, DB uppercase, dot P uppercase, everything else lowercase, positron. That's it. So if you write that on your code, you're already forcing the map to show up with that default behavior. Again, you don't have to do this if you don't want to. You can always change that on the fly by just clicking on that button and changing that option here. And actually, let me ask you this. So Neva, and I think that was that Clint in Tifton?
Yes.
Okay, so Neva and Clint, and if anyone else has had issues with this, maybe try to add this argument and run it, and let's see if that forces it to appear. Did that work, Neva, on your side? Okay. Yeah, so if you can go ahead and try that on your side, perhaps that would fix it, and if not, it's probably a version issue.
Yeah, I tried it and it's still not pulling up, which now it's giving me errors saying that stuff can't be found in the map function.
Okay, so in that case, if in your case, Clint, and potentially Neva, yes. Okay, so Neva installed MapView again, and that worked for her. Maybe Clint, if you can try that, maybe that's the solution.
Yes, I tried doing the reinstalling it and now it's not pulling anything up.
So if you reinstalled it, then we would basically have to basically rerun the script, right? Especially the parts that this piece of code requires. So here we need to create that Georgia code W object, the SOI SP22 object, and so on. So if you installed it, and now your environment on the on the right-hand side is empty, you're gonna have to basically run everything above and then run this piece of code again. Maybe that's gonna fix it. Okay, while you try that, I do want to show you the following. As we saw last class, if you were working in your code in such a way that you did not leave any errors on the code above, or really anywhere in this code, you should easily be able to come and render this, and it should render correctly. It is given some messages and warnings, but none of that is not an error, right? So if it renders successful on your side, I can open this. This is HTML. I can open this in my browser by clicking on that button right there. So this button here would pull it out on your browser. And then let's just quickly explore this. So we see everything that we're doing. I ask for code to be folded. So if I want to see the actual code, it can unfold it. It's showing us every time we printed a table, it's showing that table. If we made a map, it's showing that map. And really we've seen this before when we rendered that previous Quarto file. But one of the cool things now is that we do have our static plots that we produced, but we also have this interactive plot. And because this file is HTML, you could potentially send this to someone and say, hey, look at this. And especially if you have different layers, right? So let's say on a field, you may have elevation, you may have, slope, soil electric conductivity, soil sampling data, yield points. You may have a lot of layers that you can still make those static plots for the person to have in the report, but you can also let them play with this. So they would come here and they have all those layers, they can turn them on and off and see how things are comparing within this, right? And again, in this case, it is like a regional level type of data set, but this could easily be field level data as well, as we will see in the next exercises. And then as a last reminder, whenever you do render it, it shows you the output right here, but it's also on the same folder where you have the code. So wherever you have the 0126 NASS spatial, which in our case should be in the code folder, it also creates an HTML for you right there that you can share with anyone, and they would be able to see this HTML interactive report. Okay, so this wraps up this script here. Before we move on, I just want to ask if anyone has any issues or questions related to what we just did. Okay, I don't hear anything. So now it's 10:34. Maybe we can just take 5 minutes if you want to stretch, have some water, go to the restroom, and then we're going to talk about the mini project. So make sure you're here back in 5 minutes, and we're going to go through that. That's going to be a good chunk of your grade. So I do want you to be here when we go through the details of that. So let's just take 5 minutes break here, and then we'll be back at 10:40 to continue the class. And if you're staying around and you have any issues or questions, I'll be here. I'm just going to mute and turn off my camera, but I'll be here. I can help out if needed.
Hello, Dr. Bastos.
Yes.
Can you tell me what does legend mean?
Can you repeat that?
What does legend mean? The term legend.
Legend?
Yeah, legend.
So normally the legend would be like if you create a plot that you're assigning some like a color or fill or size or shape according to something, you need a legend to tell you what that's like, what is the relationship between that something and that color or shape, right? So the legend just creates you that key for you to know, okay, if a color is black, then it means that it has low yield, and if it is green, it is high yield, or something, something like that.
Okay.
Yeah, that would be, at least with what we're doing, that would be the main meaning of that.
Okay.
Hey, Dr. Bastos,
Yes.
there a chance I could possibly share my screen with you and Mike can figure out, Mike, so you can see what I'm looking at
Sure. Yeah.
with the map.
Yeah, so yeah, I just stopped sharing. Yeah, I think you would need to connect from your computer.
Recording in progress.
Okay, so I have.
Fred, just use your mic.
Thanks. There we go. All right. Can you hear me?
Yes. Mhm.
Okay, so this is what I'm seeing. There's just blank background, nothing there. I came up top and I reinstalled it and then I added the library package.
Mhm.
Yeah,
Did you run that library function?
I did.
Okay.
I did. And then I'm like, yeah,
So,
Yeah.
oh, sorry, I just
go
want,
ahead.
I think here may be a place that we can explore. So if you have your cursor in that row 41 of your script, where you have the map view, run just that by itself. So not the whole chunk, but just that line. Okay, so it doesn't tell us anything. So it doesn't, if something was wrong at this stage, maybe we could see through a message, but it's not telling us anything. So can you go back to that map view chunk? So the last chunk. And if you just go ahead and look, so have your cursor on that 140, on that row 148, or really anywhere after that map view, and then just run only that. So just that. Okay, so if you go back to the chunk, or I mean, just scrolling up a little bit, yeah. So if you see there, right before the map, there is so the leaflet is the actual map view output, but there's a second panel right next to it called our console. Click on that one. So it would be, so if you go bring your cursor, you can leave this, yeah, right there. Okay, so let's see what says there. Cannot create file. Okay, so my guess then is perhaps it has something to do with OneDrive. And I'm not exactly sure why this is only happening with the map view and not with ggplot or other things. But to me, it seems like there's something going on between map view and how it creates this interactive map in permissions in OneDrive. So that would be the next thing I would try is, I don't know, has anyone else have this issue where OneDrive?
About the same party right now.
Okay, so you,
I don't think it's
the package, yeah, so Clint said that he already reinstalled the package, so I'm not sure.
but I got the same.
You got the same as well, Neva, and then after reinstalling it fixed? Okay, so, Clint, can you go back to your first chunk? Let's just try to reinstall it again and see. So if you just, uncomment that and then just run that line of code. Okay, so you can say, let's just go ahead and say no right there. Because I think it would still then go ahead and try to install it. Okay, so Memphis in use and will not be installed. So I don't think it actually went through. So let's do this. Maybe we can connect after class and then we can troubleshoot more closely. Maybe there's something going on with our tools as well. So let's do that after class. And I'll, if you have time, we can connect by Zoom and then we can troubleshoot that.
That works for me.
All right, sounds great. So I'll start sharing on my side again. So let's talk about the mini project. So before we do that, make sure you save your script. So by doing that, just click on that save button. Remember that the script and the data is what you need to reproduce everything that you're doing. So we always want to save our script here. Okay, so I did upload to GitHub the mini project instructions. So if you were to go on our GitHub page, it's going to be under this folder called 06 mini project. So we're going to have to, well, if you're taking my other class, you may just do a git pull if that is working on your side. If you're not taking my other class, you can just going to have to upload this in. But basically inside of there, there's going to be a QMD, a Quarto file called mini project. That's what you're going to be working off of. I'm not going to download on my side, I already have it. So I'm just going to go ahead and launch that to show you what I'm asking of you. Just opening that QMD file here so we can go through it. So basically what I'm asking you to do is we're basically going to reproduce everything we just did together for soybeans production. However, now each one of you is going to be assigned a different data set. And what that means is also you're going to have to retrieve this data set yourself. You can follow the same instructions as we did in class when we retrieved the soybeans production one on the NASS website. And I will share with you shortly what is your assignment as far as what crop are you working with, what category you're working with. So in class, our commodity was soybeans, our category was production. Now, each one of you is going to get a different crop in a different category that you're going to download and then answer all the questions that we asked in class, but for this new data set. Of course, with that, you're going to have to do some data wrangling. You're going to have to do exploratory data analysis and so on, just like we did in class. So I just want to go through some of the instructions here. I do urge you to read these instructions and go back to them and check what I'm asking. what I've seen in the past is if you don't read the instructions, or maybe you read once and you forget about them, you will submit something that may not be what I'm asking, and then you're gonna lose points in something very silly that you should not lose points on. So if I'm asking you to do something, I do expect you to do that, and if you don't, you're gonna lose points. Very simple. Also, something else, going through the instructions here is that I'm asking you to show me, or I'm not asking for you to show me a table. I'm asking like, what is the minimum production? What's the maximum? What's the county? What's the year? You need to write down those answers, right? Just showing the table and the plots like we did in class is not gonna get you all the points. You need to do the plots, do the tables, but also write down what you're seeing and answering with words your question. Yeah.
I should be able to open that file, and it should open up in the studio. The meeting project.
You should, yeah. If you downloaded that already for GitHub and it's in your computer, if you double click on it, it should open up in any. So sometimes what happens is if you double click on the script, it will, if you have more than one RStudio window open, it may open in another one that you're looking at. So maybe check on your computer if you do have more than one RStudio window open. It may have opened, the script may have opened a different RStudio window. Were you able to find it? No.
It's trying to open now, but. There it is.
Okay.
I had to close out our studio.
Huh.
My head.
Interesting. All right, so just continuing here, what I want you to do is to get this set up, right? So as we've been doing in this class, every new thing that we're doing, we're developing a full new project, right? So what that means is going to the main folder of this course. I'm asking you to create a folder called 04 mini project, and then your full name. So let's say for me, this would be 04 mini project Leo Bastos. You go inside of that folder, you create data, code, and output, things that we have already been doing and talking about. So I hope that this sounds familiar to you. After doing all this, you're gonna move this script here, the mini project.qmd that you just downloaded. I want you to move that inside of the code folder of this overall 04 mini project folder. And after downloading the data, which I'm not providing you the data, you're downloading this yourself directly from NASS USDA, like we did in class for soybeans. So you're gonna do that on your side. And then to make sure, so you download that and then you rename it to something like commodity category.csv. So again, each one of you is gonna get a commodity that's gonna be either cotton, corn, peanuts. I think those were all the three that I assigned to you. And then you're gonna get one category that could be yield, production, or harvested area. So that's what I mean by commodity and category. So let's say for the class, this would be soybeans underscore production, right? That's how this would translate into. And then you move this data, that is a CSV that you got from NASS, you move that into your data folder. And then lastly, you're gonna create an RStudio project, the way that we've been doing, at the level of that 04 mini project folder. If you're not familiar with what I'm talking about, go back and revisit the first lecture that we had that we did create a project. You're gonna be able to see what these steps are in me narrating what we're doing. After you do that, I want you to fill your information. So both here in the body of this RStudio, of this Parto file, I want you to write your name, commodity, and category. But also I want you to add this information on the YAML of this project. So I want you, the subtitle here, you're gonna change to, let's say, the class would be soybeans production, and then your full name. And when you render this, these pieces of information are gonna show up on the top of your render file. One thing that happened last semester is, I know some of you said that you had an interest perhaps in vegetable crops or maybe tree crops. And last semester, I tried to accommodate those and say, well, if you want to work with a vegetable crop, I'm going to assign you to, let's say, onion yield in Georgia over time. what happens and what I notice is that for these other crops, like vegetable crops and tree crops, there's not as much available data on NASS. So you may have the county level data, but you may only have for like 5 years instead of 60 years that we have for soybeans, corn, cotton, peanuts. So what I decided to do this semester is to give you all crops and categories that have lots of data, because again, the goal here is for you to get used to and get more experience with data itself that's related to ag, that's related to geospatial data, and how you handle that. But of course, if on your own time, if you're interested in looking at onion yield or maybe blueberry production area or whatever it is, you can always do that, and now you know how to do it en masse. And also to make sure that you are making the correct selections, I do want you to ask you that once you go into NASS and you select all the boxes that we did in class, that you do take a screenshot of that selection and send to me. Because I want to make sure that you're getting the right data. Because what I do not want to happen is perhaps by mistake you selected something wrong, and instead of ending up with 6,000 rows, you end up with 50. And then it's going to be harder for me to grade you if you're only working with 50 rows of data instead of all the ones that you should be working with. So I do want you to send me a screenshot of your selections so I can check that you're getting the right data. And then after I respond back to you saying, yes, you got it, go ahead and keep working on your project. Then you can start developing this. Notice how I left you some placeholders, I guess. So I left you the setup placeholder where you're gonna have to load your packages and read in your data. I'm not leaving you the code. I'm not leaving you any code here. This is gonna be up to you to develop based on what we did in class. I'm leaving you just the placeholders for them. So there's setup is where you're gonna load your packages, reading your data, just like we did in class. If you're not sure what I mean by this, go back to the class scripts. You're gonna be able to see this there. EDA, so if you recall, EDA stands for exploratory data analysis. This is where we check summaries, we check variable classes, how things are being interpreted by R, and if we have to do anything that needs to be changed, that's where we determine that through EDA. And then there's going to be a wrangling part as well. If you recall, we did a lot of wrangling on this data, both on the tabular, but also on the geospatial side of things. Your chunks for doing that should be under this category here. And then I have questions. So each line here is a question, which right here on the script is not numbered. But whenever you render this, it's going to be numbered. This question is going to have numbers through them. What I want you to do is once you get into the question, you create a new chunk. So can you either push that button to create a new chunk and then write the code that you need to answer this question. After you produce, let's say, a table, you come here and you tell me, you use your words to tell me what is the answer and not just leave me guessing, just looking at a table. Yeah, so I have 13 questions for you. Whenever you're ready to submit your work, I want you to render this to a Quarto file, just like we did the last couple of scripts. Remember that if you have in your code, if you leave any errors in your code in your chunks, it will not render. So make sure that you have your code clean, that everything runs when you run one by one. Then that way you make sure that renders well. A couple of notes on rendering here that I do want to emphasize. What happened last year, and people lost points for this, is that, you're doing all this, you're working on this, and then you render, and it may not look the most professional output, but people didn't fix it, and they send me the way that it was rendered. So one example that actually Ujwal had a question earlier was you may notice that in R, so let's say you import the data that has 6,000 rows and you print that data to see it in R, it may give you just the first 10 rows. But when you render, it may actually want to show you all 5,000 rows of data in your render markdown or render HTML, sorry, which I don't want to see, right? I don't want to be scrolling for a minute to get to your next chunk. I don't want to do that. So if you run into that issue, that very specific issue of having too much being printed, you can use the head function that we went through this in intro. So head function, instead of saying df and just printing that, you can say head df, or maybe df pipe head. It's going to be the same. So you show me just the first few rows, which is really what I need to see to give you to understand what you're doing. Also, what I noticed last year is some students would come here and they basically deleted all my instructions. Maybe they were renaming, or not renaming, but they did something with the questions themselves. And whenever they sent me the render file, it was not looking like what I was expecting. What I want to make clear this time is do not delete any of my text. Feel free to add things that you want and maybe delete the things that you add if you don't think they're needed, but do not delete my instructions, do not delete my hierarchy. Because as if you recall, in our marked or in Quarto, one hashtag here is a heading 1, 2 hashtags is a heading 2. So if you come here and you change that, it's going to mess up the way that I see your report in the end. It's going to make harder for me to grade your report. So do not mess with what I am giving you as far as text. You can send me, you just add your code, add your answers, and send me everything like you're seeing here, including my text that I'm providing you. So a quick tip is, render it. If it looks professional, great. If it doesn't, if you look at it and you think, I would never send this to a job that I'm applying to, that means you probably need to work a little bit more on that and making it more professional, right? So not giving me 5,000 rows showing on your outputs is one of them. Also, there's going to be 13 questions here. I'm going to render this in a second so we can see how it looks like rendered at this stage. I do ask that you do not add more structure. So I don't want you to come here and create another like 2 hashtags and saying, I don't know, answer. I don't want that, right? Because that's going to create a new entry on my table of contents, and I don't want that to happen. So just come here and answer normally, right? So as you would be writing, do not create new entries in this table of contents on your side. Okay, so sometimes what you're going to see is when you render chunks, and for some reason that chunk give you a warning or a message. It happens sometimes when we're loading packages. It happens sometimes when we're creating plots. I do not want to see those messages or warnings. There is a way that we can inhibit those things from happening, and I'll show this in a second. So if I come here and I just create a chunk, there are chunk options that we can specify right here in the chunk itself. We start with a hashtag and a vertical pipe. And then if I hit, I'm hitting tab is not giving me anything, but there is one of them that is called message that we can set it to false. Similarly, there's one called warning, and you can set it to false. So if this chunk here produces messages or warnings, you can inhibit that behavior by doing this. I'm going to delete this because this is not part of what I sent you. It was just a demo, but this is how we would inhibit those. If you do have issues with this, you can always Google, right? How do I inhibit messages in a Quarto chunk? You're going to find an answer easy. Okay, another tip here that's very particular to I guess, programming language in general, but also to Quarto, is when you render, sometimes, if you see on the scripts that I send you, if I normally have 2 white spaces at the end of each sentence. Oh, I didn't have one here, but it would be like that. So if you render in 2 sentences that should not be connected, end up connected on a render file, is because you probably you can come back to the R code and add 2 white spaces, and that's going to make sure that when it renders, it breaks the code, right? So let's say if I had this, well, let me just go ahead and render this, which actually goes very fast because it's just text at this point. I'm going to show that to you. So this is how it looks like right now, right? So notice how I have the table of contents here with everything. As you start answering your questions, notice how they're numbered, right? So I know there should be 13 questions here. So in the past, again, some students messed up with the heading levels in the Quarto, and then they ended up having 12 questions, or maybe they ended up having 16 questions. And then I'm like, where are these coming from? Where is the mismatch happening? Which I don't want to have to do that. So help me out on that side and do not change that. So just a quick example here, right now, this these last two bullet points are not together in the same sentence. And that's because there is I added two white spaces here to make that work. So let's say if I do not have a white space, but I just hit return, maybe let's see what happens there. So we can kind of demo this behavior here. Maybe I actually did break code for some reason. Let's try one more time, and if that doesn't work, then we'll just keep moving, but yeah, so that maybe because it is in a bulleted list, maybe that's why it's not, I'm not able to reproduce the mistake I'm trying to show you how to avoid. But maybe here would be an example. Let me try this. So if you have these two sentences and you just give a return, let's see if that's gonna connect them or if they're gonna come in separate rows. Yeah, so see now here, this after sentence is in the same line as the rename, even though on my script, they are separate. Like they're in two different lines. I hit return. The issue is that I needed two white spaces here for this to actually show up as two different lines. So it's just one, technicality that I just want to make you aware. In case this does happen, you know how to fix it. Okay, let's see what else. So after you render it, and you're ready to submit it, again, make sure it looks professional, make sure that things are sharp. And then you're gonna have this HTML file in the same folder where the script is, which should be in that code folder. So what I want you to do then is rename this HTML to your last name, your commodity, and your category _ mini project, and HTML is going to be there already. So for me, it would be something like Basto, soybeans, production, mini project. And this is the file that I want you to send me. Okay, so I do not want your Quarto file. If you send me a Quarto file, I'm going to email you back saying, send me your HTML file. I want you to send me the render version, so the HTML. Do we have a question online? Maybe not.
I think that's just like people walking in the hallways coming through.
Okay, good mic. All right. So then once you do that, you will submit this HTML to my email by February 14th, 11:59 p.m. So you basically have just, I think, maybe a little bit over 2 weeks from today. A word of caution I would give you here is this is not difficult. We have already made all of this with the previous exercise in class, right? So it's not like I'm asking you to go out and find out how to do all this. No, we have already made this. You're basically just going to have to adapt what we did in class to this new data set that you're going to download. So it's not something super impossible. It's very, very doable. One thing I would say is if you do have questions, you run into issues, create a GitHub issue. Remember that asking on GitHub and especially helping others that ask on GitHub gets you participation points. So I do want to use GitHub in case you run into issues. Remember, if you run into an issue, show the code, show the error, show the output so a person can try to understand what's going on and help you that way. I do want to say that, of course, I'll be available to help you in case GitHub is not being helpful or maybe you cannot figure something out. I will help you out. However, even though 2 weeks seems like a lot of time, is going to go by really fast. And especially because you have to share a print screen of your data before you even get started, so it can give you the heads up or the thumbs up saying that you have the right data. I would say do this soon, start soon. Especially, again, because we're working with a programming language, and it may be that you're following exactly what we did in class, and for some reason, you're getting to an error. I will be there to help you. Your colleagues will be there to help you. Google and ChatGPT as well. But this is due, about 2 weeks from now. So if you send me an email on February 13th saying that you cannot enter or read your data into R, there's only so much I or anyone else can do for you, right? So make sure you start on this. You're gonna run into issues. That's common, that's expected. We're here to help each other. And we're gonna give you that help if you need it, but do not leave this to the last minute. Okay, this is all I had. Any questions about the mini project?
How do I make an R project about this? Like in the mini project folder, I just start the project there, right?
Yeah, so you can come here. So in any RStudio window, you go on that right-hand side and you click new project. And then you go on existing directory. And then you browse to the folder where that is. So in my case, it would be 04 mini project Leo Bastos. This is where you want to create that project.
Okay, yeah.
Any other questions at this point? Yes, Niva.
With which from? We are
Oh, yeah. Thank you for reminding me of that. I was actually forgetting. So your commodity and category assignments are on the website. So if you come on advanced topics in precision ag, it's gonna be right here. So for today's class, there is this icon for the lecture, which is not a lecture, is just your assignment. So here you're gonna be able to find your last name, your commodity, and your category. And the commodity and category are the names I'm using because those are the names that you're gonna find on NASS. So go back to the lecture where we downloaded the data from NASS and see exactly what we did in class and just make sure to change your commodity and category. And you should be able to get the correct data. All right, so the assignment of your commodity category, if you want to take note now, you can. If you want to check it back later, it is on the class webpage. I also want to make sure I go on GitHub and open an issue for attendance for today. All right, I just open an issue for attendance. Make sure you claim your attendance. And if you don't have any other questions, you're dismissed. I'll hang around for another couple minutes in case anyone has questions about the project.
Yeah, I have one. This project that we'll be doing, we will be doing on the county level of Georgia state only, right?
So the question is if it's county or state level?
Yeah, the project that you have given us, the way we will do just like on the county level of Georgia state, right? Because I think on that website there is a lot of data, but we have to filter it at the county level for the state Georgia.
That's correct. Yep. So I would highly recommend that you go back to the lecture that we had exactly what you should select on NASS to make the proper selection. But yeah, that's correct. It's going to be the county level historical data related to your commodity and category.
Okay, thank you.
Any other questions? All right, I don't hear anything, so I guess we're done for today. Thanks, everyone.